Welcome back, everyone. I'm Michelle Saner, and today we are going to be doing some stoichiometry practice problems. Now, these are probably some of the hardest problems that my students have trouble with in chemistry, and I thought I'd spend some time going over a few of them today. So I'll do some with you, and then I want you to also practice pausing the video and trying to work through them yourself, and then unpausing them and checking your work as we go. All right, so let's talk about stoichiometry. The first type of problem you might encounter is one that starts with the number of moles of one of the substances in the reaction. Compare it to a different number of moles. You're trying to convert between moles of substance A and substance B. So let me show you a little handy little stoichiometry mental map that might be useful to you. If you are working between moles of a substance and you want to convert to moles of a different substance, then this is the bridge that will get you there. You'll need to use the mole ratio. How many moles of substance A correspond to how many moles of substance B? And you get that information from the balanced chemical reaction. All right, so let's take a look. So how many moles, this is kind of what the question is asking. So this is what I'm trying to solve for. Find how many moles of HNO3 will be produced when, and here's what's given to us, 0.51 moles of N2O5 react. We also have this equation here that compares these two quantities. So it looks like for every, and remember there's an implied 1 here, for every 1 mole of N2O5 that react, it's going to produce 2 moles of HNO3. So it has a mole ratio of 1 to 2. This is a true statement that compares how many moles of the reactant you start with and how many moles of the product you're going to get out. So this is called the mole ratio. All right, let's use it to solve our problem. Always start with the given, 0.51 moles of this first substance, N2O5. I'm going to go ahead and set that over 1 just so I remember that it's a numerator and it's going to get multiplied. Even if I had no other tools at my disposal, this picket fence technique says, listen, in the next step, drop that unit down, moles of N2O5, so it can get canceled out. And so now I'm ready to use my mole ratio. It says for every 1, and remember this 1 is tied to the substance, 1 mole of N2O5 that react, I will produce 2 moles of HNO3. So a true statement here. This is where my mole ratio goes in this next step. We want to cancel the unit, moles of N2O5. And now that I'm done, if I stop, I will have an answer that is in the units of mole HNO3. And if that is the same as the find, then you're done. Your equation is set up correctly, your picket fence and unit analysis has been taken care of, and now you can do the math. So punch it into your calculator, 0.51 times 2 divided by 1. So everything on top gets multiplied, everything on the bottom gets divided. All right, see what you get. All right, I put it in my calculator and I get 1.02 moles of HNO3. So we'll try it again, but with a different problem this time. It's another mole-to-mole problem. And I want you to try it on your own before I show you the answer. How many moles of NABR will be produced? So this is the find. Trying to find the number of moles of NABR. How many moles of NABR will be produced when, and here's my given, 0.39 moles of bromine gas reacts according to the following equation. So we need to make sure we determine the mole ratio. I see 1 mole of bromine are going to react to produce 2 moles of NABR. So write down your given, write down your find, write down the mole ratio that compares the reactant to the product, and see if you can set this up on your own. I'll pause the video and you do the same, and we'll see how you did. All right, team, how'd you do? I started by putting the given 0.93 moles of bromine gas, Br2, in the top and set it over 1. And I did that just to remind myself that this quantity of moles of bromine gas is going to be multiplied. Then I dropped that unit, moles of bromine gas, down below so it would cancel. And in this step, I used the mole ratio that I got from the balanced chemical equation here. That compares, says for every 1 mole of bromine gas that's used, I'll produce 2 moles of sodium bromide, NaBr. Then I punched 0.39 times 2 into my calculator, and I got 0.78 moles of sodium bromine. All right, I hope you did well. Let's try another one. How many moles of hydrogen gas will be produced if 0.44 moles of this calcium bonded to hydrogen here reacts according to the following equation? So set up your given, set up your find, identify the mole ratio that's going to be the most useful to you. It should be between the hydrogen gas and the CaH2. And see if you can solve this problem. Pause the video and we'll see how you did. Okay, how'd you do on your own? I started with a given that I would begin with 0.44 moles of CaH2. I set it over 1, so it would be treated as a numerator and get multiplied. Then I put in the next step the mole ratio. I chose to put moles of CaH2 on the bottom. That way they would cancel out. And that way I would be left in moles of H2, which is what I'm trying to solve for. So once again, I use this mole ratio, which came from the chemical equation here and here. Punch it into my calculator and I got 0.88 moles of hydrogen gas. All right, let's try another one. Here's our final mole-to-mole problem. How many moles of oxygen, and that's O2, will be needed to react with 0.38 moles of C3H8 according to the following equation? So we will be comparing these 5 moles of oxygen to the C3H8. And this time we're comparing 2 reactants to one another. We could do that. We just have to look for the mole ratio of those 2 reactants. So pause the video, see if you could set it up on your own, and then start it when you're ready. All right, how'd you do? I started with 0.38 moles of C3H8 in the top and set it over 1, so it'd be treated like a numerator. Then in the next step, I found the mole ratio from the balanced chemical equation. It says that 5 moles of oxygen need to react with an implied 1 mole of C3H8. So I used that mole ratio here, and I chose to put C3H8 on the bottom so that it would cancel out. Now, if I were to do the math, I'd be left in units of moles. And when I punched that into my calculator, I got 1.9 moles of O2. All right, so that's it for mole to mole. Let's start solving some of these gram to gram problems. And these are a little bit trickier because it asks us to do a little bit more work. But if you think about it, it's just a mole to mole that converts into units of grams at the end. So let me show you what I mean. Determine the mass of lithium hydroxide. See, so that's this one. That's what we're trying to find. When 0.38 grams of lithium nitride, that's my find, anything that has a number attached to it, Li3N is my given, reacts with water according to the following equation. So it looks like I am focused on this reactant and this product. But here's an interesting thing. A lot of students get tripped up here. It says determine the mass. And they say, well, I don't know how to find the mass. You do. Remember, mass is the units of grams. So we're trying to find the amount of grams of lithium hydroxide that will be made. So let's take a look at our map and see what steps we have to do. So it looks like this time I'm going to be starting from the mass of substance A. And before I can use this mole ratio here, I need to first convert from grams into moles of that substance. And to do that, I will do the molar mass. I will add up the molar mass from the periodic table. Then I can convert from moles A to moles B using this mole ratio. And lastly, I can use the molar mass of substance B to convert into the grams, convert from moles to grams. So this is going to be a multiple step problem, but they're all things we've already done before. We've already converted between mass and moles of a substance. We've already converted between moles of A and moles of B using the mole ratio. We just did that. And then we've, again, already solved something in terms of moles or grams. We can convert based on the molar mass. So let's do it together. All right, coming back up here. Given that I want to start with lithium nitride, I can't use the mole ratio until I have actually determined the molar mass of this. So starting with 0.38 grams of Li3N, lithium nitride, set it over 1. In the next step, I wish to convert from grams of lithium nitride to moles of lithium nitride. And the way that I do that is by using the molar mass. Molar mass just has to be calculated based on the periodic table. So let's see, we have 3 lithiums and 1 nitrogen. Looking at the periodic table, I see that lithium has a molar mass of 6.94. So I'll go 6.94 plus 6.94. Remember, I have 3 atoms, plus 6.94 plus, and now we're going to do the nitrogen. Nitrogen has a molar mass of 14.01, so I'll add that in as well. All right, adding those things together, 6.94, 3 times over, plus 14.01. And I get 34.83 grams per mole. So what that means is that this 1 mole of lithium nitride has a mass of 34.83. All right, so let's see what I've done with my units. I've canceled out grams, canceled out grams. Now I'm in units of moles of the first substance. So next step, we're going to use the mole ratio to convert from moles of the given to moles of the find. And the finder over here, LiOH. In this step, I'm going to use the mole ratio again, just like we did in the problems above. And this mole ratio compares the two substances per their chemical equation. So I see that there is 1 mole of lithium nitride reacts, and look at that, it produces 3 moles of lithium hydroxide. So I'm just taking the coefficients out of the chemical reaction and plugging them in. They are my mole ratio. All right, so moving along, I have taken moles of the reactant and canceled it out. And now I'm in moles of lithium hydroxide. If I were to solve right now, I would have an amount of lithium hydroxide. However, I want that amount expressed in grams. So my last step is just going to be to convert moles of lithium oxide to grams of lithium hydroxide. And once again, I'm going to use that molar mass to do so. But this time, I'm going to use the molar mass of this other substance, lithium hydroxide. So looking at my periodic table, I need to add up 1 lithium, 6.94, an oxygen is 16, and a hydrogen is 1.01. So that was 6.94 plus 16 plus 1.01. And the molar mass of that, punching in my calculator, I get 23.95 grams per mole. That is to say, 1 mole of lithium hydroxide has a mass of 23.95 grams. And now that my moles cancel, I am left in units of grams of lithium hydroxide. I am ready to solve. So everything on the top, remember, must get multiplied. 0.38 times 1 times 3 times 23.95, divide by 1, divide by 34.83, divide by 1, divide by 1. That's how you want to punch it into your calculator. And if I do that, and you do it too, pause the video and you try it too, and see if you can come up with the same value as me. And that way you know you're operating your calculator correctly. Okay, how'd you do? I punched it in my calculator and I got 0.78 grams of lithium hydroxide. So we've got a lot more gram to gram problems to try. So I want you to try the next one on your own to start. Determine the mass of carbon dioxide, so that is CO2, produced when 0.85 grams of butane, and that's C4H10 right here, reacts with oxygen gas according to this equation. So we are converting from grams of butane to grams of carbon dioxide. Set up your given and find, pull out any mole ratios you might need, and Also, try to figure out the molar mass of each of those compounds. That way we can convert to and from. Pause the video and see how much you can do on your own. Okay, here's how I did it. I started with my given and set it over 1. I did that so that my grams would be treated as a numerator. And in the next step, I found the molar mass of C4H10. And the molar mass was 58.14 grams per mole. So I chose to put grams down below so it would cancel out. In the next step, I used the mole ratio from the balanced chemical equation. That said, for 8 moles of carbon dioxide will be made from every 2 moles of butane here. So I chose to put moles of butane on the bottom. And the reason I did that is so moles of butane and moles of butane canceled. And then my last step, if I were to solve now, I would have moles of carbon dioxide, which is good. That's the substance I want. But I wish to express it in grams. So in the last step, I found the molar mass of CO2. So I took a carbon, I added it to 2 oxygens from the periodic table, and I got 44.01 grams per mole. I choose to put moles of carbon dioxide on the bottom, so it would cancel with moles of carbon dioxide in the previous step. And I'm left in units of grams of carbon dioxide. Once I punch that into my calculator, I come up with 2.57 grams of carbon dioxide. All right, we've got another gram to gram problem here. So we're trying to determine the mass of antimony. And antimony is this fellow right here, SB. So how many grams of antimony is produced when we start with 0.46 grams of antimony 3 oxide? Set up your given, set up your find, pull out any mole ratios that you're going to need for this problem, and calculate any molar masses for the given compound and the find compound. Pause the video and see how you do. All right, I'll show you how I did this. I started by taking the given antimony 3 oxide and setting it over 1. The next step was to convert from the grams of antimony 3 oxide to the moles, and I did that using the molar mass. And so that basically just expresses, given a mole of antimony 3 oxide, how much does that weigh? I chose to put the grams of antimony 3 oxide on the bottom. That way they would cancel with the grams in this previous step. In the next step, I compared my given to my find by using the mole ratio. I see from this balanced chemical equation that it requires 1 mole of antimony 3 oxide to react to produce 2 moles of antimony, the element. So it's a 1-to-2 ratio. And I chose to put moles of antimony 3 oxide on the bottom because I'm trying to cancel that out from the previous step. The last step was to then look at the molar mass of pure antimony. And I saw that according to the periodic table, a mole of antimony had a mass of 121.76 grams. I chose to put moles of antimony on the bottom so it would cancel, and my final unit would be in grams of antimony, which is what I'm trying to find. Once I punched all that into my calculator, I got 0.38 grams of antimony. Okay, we've got one more for you to try today. So do your best to try this on your own as much as you can. This final problem for the day asks you to determine the mass of sodium nitrate produced. So here is our sodium nitrate. When 0.73 grams of nickel 2 nitrate, and that is here, reacts with sodium hydroxide according to the following equation. So they give you a lot of information here, but you can ignore everything except the given and the find. So set up your given and your find, identify the mole ratios you're going to need, and calculate the molar masses for the reactant and for the product so that you're able to convert between grams and moles. Pause the video and see how far you can get. All right, let's see how you did. I started with the given 0.73 grams of nickel 2 nitrate, setting it over 1. And in the next step, I calculated the molar mass of this reactant. And I did that so that I could get it into units of moles. It's only once you're able to convert into units of moles that you are able to use the mole ratio. And mole ratio is the only bridge that gets us from substance A, compares it to substance B. So the only way to go from moles of nickel 2 nitrate is to compare it to moles of sodium nitrate. And I did that by seeing that there was a 1 mole to 2 mole ratio. And I just left those, brought those coefficients along for the ride in our mole ratio step. In the final step, when I had solved for moles of sodium nitrate, I once again used molar mass to convert from moles to grams of that same substance. I choose to put the 1 mole down below and then molar mass up top. And again, this is just taking from the periodic table 1 sodium, 1 nitrogen, 3 oxygens, and adding them all up. And that's what the molar mass is. So now I know that I am done because my final unit matches what I'm trying to solve for. Punch it in my calculator, and I got 0.68 grams of sodium nitrate. So I hope me doing these together with you kind of give you a little bit of a window into how I like to solve these problems. It's a really effective strategy, the picket fence, even though it can seem kind of cumbersome at first. It's a way of kind of checking your work and making sure that the math you're about to do is the right operation. So I hope you're doing well and you have a great day. And when we see each other next time in class, we'll do some more of these practice problems together. Take care.